In this exercise, we have to translate this formula to CNF and DNF. If you look at the algorithm, the first step is about eliminating XORs, but fortunately there are no XORs in our formula, but we now have an equivalence. So according to the second step, let's get rid of equivalences. Whenever we have an equivalence, we can translate it to two implications. Implication, which implies the right-hand side from the left-hand side, and another implication in the other way around, and they are connected with a conjunction like that. So this is what we are going to apply right now to this part of the formula. Okay, so what was it? Yes, so P implies Q and Q implies P. And this is the left-hand side. This is going to be the left-hand side of the main implication here in the middle with R or S on the right-hand side. Okay, so now let's apply the third step, which is about eliminating implications. This is something we already know how to do. We negate the left-hand side or the right-hand side. I apply this to the second implication as well. And if you don't mind, I would like to apply it to the third implication at the same time. Of course, this requires the entire left-hand side to be negated. However, now we can apply a very simple simplification. We can remove those parentheses because we have two disjunctions next to each other. Okay, guys. So now let's deal with, of course, the negation in front, because the next step is about moving negations inward by applying the De Morgan laws. Now we have a negated conjunction. Therefore, we have to apply this law. So we turn it to a disjunction. Okay, so how to do that? Of course, we have to negate the left hand operand. Then this conjunction turns into a disjunction. Then we negate the right hand operand. And finally, I keep the rest. And we are done. We are not done yet with the step 4, because there are two subformulas to which we can apply the Morgan laws. So this is what I'm going to do. Here, this subformula turns into P and not Q. This subformula turns into Q and not P. And that's it. So now we are done with step 4. There is no more negations which can be moved further inward, right? All the negations are already in front of Boolean variables. Okay, so what about this formula? Well, this formula, is this formula already either in CNF or DNF? Yes. This formula is in DNF for sure. This is a DNF. Okay, so how can we turn it into a CNF? There is only one way, and you can find it in the algorithm. Step 5. Step 5 it is about swapping conjunctions and disjunctions. Basically, this is what we have to do. In DNF, we have conjunctions inside the parentheses and disjunctions outside. They have to be swapped. We have to move disjunctions inside the parentheses and conjunctions outside. And there is only one way to do that. There is only one law which can help us. This is the law of distributivity. Yeah, so how to do that? We are in this situation. We have disjunctions outside and conjunctions outside. So we have to form pairs out of operands like that. And this is what you will get. Okay, so we have a very long formula here. Therefore, what I'm going to do is the following. I'm going to apply the distributive law to this part first, and then we will see what is going to happen with the rest. So here, I'm going to form a pair of this guy here and P, and E. This will be the first pair. The second pair will be almost the same, but with not Q instead of P. So from this part, we are going to get the following: P or Q and not P, or, and not Q or Q and not P. Exactly. So again, what I was doing, what I have done is that I translated only this part to this formula. I'm not done yet because this looks pretty messy. We have also to apply the distributive law here and also to here. So if I apply the distributive law to the first part, I get P or Q and P or not P. And now the second part is coming, not Q or Q and not Q or not P, right? Okay, now this looks promising because we have very interesting formulas here, sub-formulas. P or not P, Q, not Q or Q. Well, you probably remember that we have a simplification rule. I cannot show it to you, but you should remember, which simplifies such formulas to 1, both of them to 1. So basically what I get is P or Q and 1 and 1 and not Q or not P. And you should also remember that whenever you have a conjunction like this and any of the elements is 1, then you can remove them. They don't do anything inside a conjunction. So finally, we get a simple conjunction with 2 clauses, basically, and this is it. So this is what we got from this formula here, and this is what I'm going to copy there, or I don't know how to do this. Maybe I will do the following. I will copy the rest of the formula to here. Yeah, maybe this will be much more feasible. But let's not forget about to put the parentheses here, because now we have a conjunction inside and disjunctions outside, and it would be dangerous to get confused between them. Okay, what's going to happen? Well, surprise, surprise, and we are still running, we are still executing step 5. Step 5, we have to apply the distributive law to this formula because this is not CNF yet. And this is what we are going to do. Basically, we have to form pairs of those guys. So this is going to be the first pair, this is going to be the second pair. And let's see what we are going to get. P or Q or R or S, and not Q or not P or R or S. Of course, meanwhile, I removed a few unnecessary parentheses. This is what you can see now is a CNF. This is a conjunctive normal form, since outside of the parentheses, the main connective is conjunction. And inside the parentheses, we have only disjunctions. So yeah, this is a pretty CNF, what we got here.